So we're looking at question number 56, and it's asking us to solve the logarithmic equation. And be sure to reject any value that is not in the domain of the original logarithmic expressions, as well as give the exact answer. We're given the logarithmic equation, log base 9 of the argument x plus 2 minus the logarithm of base 9 with the argument of x is equal to 2. So the first few steps I like to take to solving logarithmic equations are going to be step 1, you're going to condense your equation using logarithmic properties. Step 2, you're going to change the form, and I like to change from logarithmic to exponential form just because it makes it easier to solve for x. Step 3 is going to solve for your x, and step 4, you're going to check your solution. So now that we have that written out, let's go ahead and start solving this equation. So let's start by condensing. We already know that since this has a subtraction between the two logarithmic expressions, we're going to be using our quotient property, meaning we're going to have our two values, our two arguments divided by each other. So let's rewrite this. We're going to have log base 9 of our first argument, x plus 2, divided by our second argument, x. That's going to be equal to 2. Now that we have this written as one logarithmic expression, we can go ahead and change it into exponential form. So when you're changing between the two forms, exponential and logarithmic, it's good to remember just a standard equation. So for that, for your exponential, you have b of x is equal to y. In your logarithmic, you have log base b of y is equal to x. So for our given equation, we know that in our logarithmic, b is 9, y is x plus 2 divided by x, and our x is 2. So we can go ahead and change to our exponential form by putting in the same value. So b, 9, x is going to be 2, and y is going to be our argument x plus 2 divided by x. So let's rewrite this on the left-hand side. You're going to have 9 raised to the power of 2 is equal to x plus 2 divided by x. Now let's go ahead and simplify this. I'm going to just go and square our left-hand side. This will be 81 is equal to x plus 2 divided by x. We want to get rid of that x in the denominator, so we're going to multiply both sides by the x, so we can cancel out the denominator. We're going to be left with 81x is equal to x plus 2. Let's isolate our x. Let's move this one to the left-hand side. That'll get us 80x is equal to 2. Divide both sides by 80. And you will get that x is equal to 1 divided by 40. So let's go ahead and check this. So I'm going to look at the domains of my original logarithmic expressions to make sure that this x value is not rejected. So to do that, you're going to take both of your arguments of your original expressions or set it greater than 0. So when you have x plus 2 greater than 0 and x is greater than 0, you're going to isolate that x, and you're going to get the domain x is anything greater than negative 2 and x is greater than 0. So we know that 1 divided by 40 is in fact greater than negative 2, and we know that 1 divided by 40 is greater than 0. So let's go ahead and plug this back into our original logarithmic equation in our calculators just to make sure that this does work out. So when I plug this into my calculator, I'm going to go ahead and go to my math key. I'm going to go down quite a few clicks to where you get to log base, click enter, and this way you can edit your base. Instead of it being the usual 10, we're going to have 9. I'm going to put in my argument. So for our first argument, we have x plus 2. So I'm going to put 1 divided by 40 plus 2. And our second expression is the same thing. So I'm going to go down this. I'm going to go to my math key, click down, go to log base, click enter, insert my base of 9, and then my x value, which is 1 divided by 40, and this should equal 2. And as you can see, this does equal 2. So we know for a fact, after checking it and making sure it does not become rejected by our domain, we know that our x is 1 divided by 40.